Alright, so we're going to do the cutouts now. So we're going to start off in the right plane sketching, and I'm going to check out our pictures here. We've got, so the cutout starts just a little bit outside of the outer hub diameter, so 0.75 instead of the 0.7 we had here. And also we have here the measurement of the spokes, so they're 1/8 inch here, 0.125. And there's 4 of them, and you can kind of see there's a radius on each corner. So we're going to use the circular pattern. We just need to draw one of these cutouts and then pattern it around the circle. So if we start our sketch, we can start with, let's say we were going to make a center point arc like that. And then if we do it the wrong way, we can just sort of back it up. There we go. And let's close this up, just to start off with the concept here of the cutouts. And we're going to need to use our use some references to get those measurements accurate here. So we know that this was, from our measurements, it was 0.75 from here. So we could, or a 0.75 inch diameter. So we could just straight up go and tell this that it's 0.75/2 and give this, just for illustration now, an arbitrary one. And let's say we use this sketch to make a cut. So it's coming from that side, so that won't do anything. So we're going to make it through wall, and we need to flip its direction. So that's going to start off looking about right, but we want to just keep this sort of more true to the way it's manufactured. The intent of the dimensions here is that there's a small a space here between these two radii, and I know that Aero manufacturing produces a bunch of these wheels with different versions of the same design. So like in your shop you might have this 3.25 inch diameter wheel, and there might be also some 4.5 inch diameter wheels that look the same in terms of their geometry but are different sizes. And in that case you would want to take this stock part and just save it as a different diameter and then modify as little as possible. So in general, it's good practice to, instead of doing what we did, take measurements relative so that the intent is there, and if you change something, the intent is still there. To illustrate that, we can go and, what if we go back here and we started to change this wheel to be more like a 4.5 inch wheel, let's say. So we could start here, tell us that it's 0.5, and then whoops, we have kind of a bit of a mess that doesn't look the way we want it to. We have to go and find which other dimension to change to make it how we want it. So instead of that, we're going to use a relative reference, and it'll be able to update whenever we change it. So if we go back here, let's get rid of this guy. So this one's unconstrained now, and we have this from previous sketch we can use, but we really want to take one of these, either this guy or this guy, and we can project with this projection. Convert entity is equivalent to projection. It'll take this plane and sweep it out, and then anything it intersects will project itself onto the plane that we're sketching in. So you can see that worked, and we could use this as a construction, but we're going to be we're going to be changing the, I mean, this is going to be filleted later. It's kind of confusing if we're going to be projecting things that get filleted later, then it could get kind of messy. So let's not do that. Let's instead, we know that no matter what we do with our features, if we fillet this edge, our sketch will still be there. The sketch will be still the same thing. So we'd like to refer to that instead. So how about we make a circle about where we want it. And let's make that circle coincident to here. So that's going to be a construction because we don't want the cut to go all the way down to there. So, and we don't want the cut to include all this circle. So that's for construction. And now we can refer to it and tell us that this is 0.05/2. And that now, if we were to exit this sketch, so that looks the way it should, the way we want it. And if we go back and change here to 0.5, there we go, a cleaner wheel with less work. So that's why we're going to use those sort of relative smart dimensions here to upstream sketches. So if we go back, and let's just Control Z that size change. So we're going to need to, give this fillets, give the right spoke width. So it's going to be more convenient to, let's say, map out a 90-degree or a 45-degree segment and do the pattern off that. So let's go back in here and make some more reference geometry for us. So how about we that's not what we want it to look like. Something like this. So let's map out a section of this symmetric section, a 45-degree segment here. So let's just hide this so we're not referring to two different sketches at once, just so we get one. And actually, let's first visualize that one and hide this one. And we're just going to make a line over there. And then how about a 45-degree line to that? So let's just get that at 45 degrees. Make these construction. And we also know that we're going to cut out the same gap here on the top, on the inner wall of the rim here. So let's make another circle like that. So this guy. Now we could use either of these sketches. May as well. Actually, this one is already in the right place, so we could already take a measurement off that one. Okay, so, that's telling us that we're having overdriven constraint here because I forgot to delete this 1-inch radius over here. So in that case, we can choose which of these drives the dimension. So if we leave our new dimension driven, then it's just going to be sort of a reference measurement. If we make it driving, we're going to have some overconstrained some over constraints here we can see. So if we chose instead to leave this driven, then you can see it shows up gray, so it's not a real constraint, it's just a measurement, and you can actually refer to it. So sometimes it's useful to just have a reference measurement. But in this case, we are going to get rid of this guy. So we have to get out of here, delete that one. And then this is a measurement, so it's telling us we can't change it, it's just a measurement. But we're gonna go in and tell it to be not driven. We could have also just deleted it and remade it again without this 1 inch radius, and then it would be able to tell that we implicitly want it to be driving that. So I'm gonna go here and change this to 0.05 over 2. So that's good. Now we're definitely going to want, so let's say, I'm gonna bring this up here. Let's say we're gonna cut out this 45 degrees, make these circles here so that it's smooth, and then reflect that on this side so we have sort of a cutout on the top, and then we'll do a circular pattern all around. So here, this guy we can already tell we want it to be collinear over here. The other one, we can tell it we want collinear over here. And then we have to make the radii over here. So we actually, if we do a full, so if we do this 45 degrees and then reflect it to the other side, and that's 45 degrees, we're cutting out a full 90. And if we circular pattern that 4 times, the whole circle will be cut out, except for whatever radii we give down here. So we actually need to account for the spoke width over here. So for that, we're going to make another line, and these yellow ones coming out here, these yellow indications is helping me to create something to add auto sketch relations that I implicitly might want. So in this case, this long yellow one is a perpendicular down here, which I might not want. So sometimes if you don't want that, you might just want to, instead of bringing it close to that line, just purposely put it somewhere else so that it only created here the coincident, which is all I want for right now. So I'm going to make another coincident, make this line parallel to here, and then I can give this guy a dimension of 1/8 over 2. So is that it? That's 0.125 over 2, there we go. So that's half the width of a spoke. So that'll help us to create the spoke. So the other side of the spoke is going to be here. We can start filleting in here. So we're going to create the other geometry here. So let's get tangent arcs. So we need endpoints to make tangent arcs actually. Let's make a circle instead. And we can choose that to be tangent here, tangent here. So that can kind of be one of our fillet radii, and we're just going to end up taking this portion of it. And let's do that for the other corners. So actually, well, this side is going to be reflected, so we don't actually need it on this side. We really need it on this side over here. Tangent to you. Tangent over here. Let's make another one down here. Here. Whoops, I chose the point by accident. Okay. So we kind of need a measurement now, what the radius of the circles is, and that's a bit hard to measure the radius. You could take several convex shaped, let's say if you have some cartridge bearings or something of this approximate size, and put them in there and then see if they fit well and measure the diameter of that. It might take a few trial and errors to get the approximate radius there. So let's just say here, I'm just gonna do it until it feels about right. So for now, I'm gonna tell this one to be 0.5. No, that's too big. Let's say 0.3. This guy, let's try 0.125 to start out with. So you can kind of see how we're going to use this line will be part of the cut, then we'll transition into the circle, then this outer line. All of this will be the mirror line for the cut, and then this over here, and we'll do that part of the circle. So, but we're gonna do this cut in 2 stages actually, I think, so that we can easily go back. This is a pretty clean sketch. If I start adding to this, cutting out, trimming, I can go over here and use, let's say the trim. A lot of people like this power trim just to start editing your sketch, but it starts to get more complicated. You can end up with things you accidentally didn't want. So this is a pretty simple sketch. I'm going to do it in 2 stages instead of cutting this up. And SolidWorks does have some amazing trim options here. You can do the outside, the inside, corners, and power trim is usually, it gives you what you need for most situations, but sometimes you need to use these other options. But when we don't need it, let's not use it. So let's instead go ahead and, so this is not a proper cut because it's not a closed sketch. It has a lot of different, well, it's closed, but it's closed in multiple places. So we're going to get out of here and delete the feature. I'm going to rename this. So cutout, actually reference for the cutout. And then, actually we should go back in here and make all this construction. So we have that. It's been hard to see right here, but we can also actually just hide this guy and just work in terms of these few lines that we need here to actually see what we're doing. We can even turn these off also to have a better view here. So let's make a new sketch in the right plane and use these guys as references. So we could go ahead and sometimes it's kind of nice to just go ahead and project the ones you need in, and then trim out the parts of it you don't want. You can even try just power trimming. So you can see that turned blue for a second. I wasn't quite sure for a second. You can end up with kind of accidents that that's not what we intended there. If we get messy with power trim, you can go and carefully do it with the corner trim, outside trim, things like that, and keep these all as projections. But projections, I would use them only when you need to. So if it's not too much extra work to actually create these lines bit by bit. So let's go ahead and make a arc there. Arc here. So these are going to be radial, that will occupy the same space. This and that will be, actually, yeah, we can merge these. And we want these to be tangent, which I think is implied anyway. Let's see. Yeah, that didn't add any constraints, so that's implied anyway. So we're going to use a line on here that is linear. You can merge these guys. They're fully constrained, so they don't need any more. Same thing over here. Do it this way. Like that. Radial. Merge these guys. Same thing up here. That's going to be from here. Radial, merge these guys, and this I can make coincident to that guy. Alright, so that's cleaner than that projection. We just started trimming everything. There's not as much going on here. It's clear what we're looking for if we need to go back and edit things later. Close it up, and we can visualize here again. So how are we going to use that? So we could just go ahead and cut through all this way, and that's starting to look a bit like it. Need to mirror it. We could mirror this pattern in the, I believe it's the front plane. So that gives us one of those cutouts. But now we could go ahead and make a circular pattern of that. So we need our axis again. So let's go ahead and that was in here. If we visualize that, we can take that axis and make this 90 degrees. So that looks pretty good for now.